The following video is about volume of pyramids and cones. So, just a reminder from last week, volume is the amount of three-dimensional space taken up within an object. Uh, and we're going to skip right to it. I'll kind of put a video on the side of the screen explaining why some things are going on. But last time, we learned that the volume of a prism or a cylinder, they both had the same volume formula, area of the base times the height. And that's because as you're moving all the way up the figure, we have basically, as we showed in that milk video last time, circles were constantly getting added to the figure, and it was taking a bunch of areas of circles and combining it all the way up so that it fills the entire space. But when we're dealing with a pyramid or a cone, it's pretty clear that, let's just say I have a pyramid. That's not happening if I fill this up all the way. So if I start to fill this up, notice that the square or whatever shape it is getting smaller as I go up to the top. So the further I go up, the smaller the shape gets. And that's pretty clear that I can't just do area of the base times the height, because the area of whatever the shape the base is getting smaller and smaller as we go up. So the volume formula for a pyramid and a cone is 1/3 area of the base times the height. Why 1/3, you ask? Well, as um, as we continue to just kind of show what's going on, um, if you take a pyramid, as is shown in the video that's in the bottom right part of the screen, and you fill it up with some kind of liquid, and you pour it into a prism that has the exact same shape of the base and the exact same height of the figure, what you'll see is that it takes 3 pyramids to fill up one time of the of that prism. And likewise, it would be the same for a cone. Therefore, when we do the volume formulas for pyramids and cones or any one base figure, we get 1/3 the volume that it would have been if it was the exact same base and exact same height of a 2 base figure. So let's quickly find volumes. So if we're going to find the volume of this square pyramid that we found in the surface area video, we have the area of the base. So remember, formula is 1/3 area of the base times the height. Area of the base is 100 centimeters squared, and the height is actually given to us in this problem. So that's 12 centimeters. So all I have to do is 1/3 times 100 times 12, and I get 400 centimeters cubed. Just a reminder, when we're doing volume, we do centimeters cubed, and when we're doing surface area, we're doing whatever the units are squared. So that one was pretty easy. This one's going to be a little bit harder. If you forgot how we got the radius to be 7, watch the last video for this problem. So we know that the radius is 7. Then the slant height is 25. Well, the slant height really helps us for area because we're talking about the thing we can touch. However, we want to find the volume, and when we're finding volume, we want to fill the shape up. And so when we're filling the shape up, we want to talk about the regular height. And so in order to do that, we're going to have to do, once again, the Pythagorean theorem. So 7 squared plus h squared equals 25 squared. If I solve the Pythagorean theorem, I would get 24 feet. And so this is 24. So I have the volume is 1/3 area of the base. That's 7 squared times pi for the area of a circle, pi r squared. So that's 49 pi. Then I multiply that by the height of the figure, which is 24. So 1/3 times 24 is 8. So I really just end up with 49 times 8 times pi, which is 392 pi feet cubed here. And then that means that if I want to, I can type that in the calculator. and get an approximation. So the volume approximation is 1,231.503 feet cubed.